Hello everyone, and welcome to our presentation. This is Joe Carcare with Belimo Air Controls, Product Manager for Retrofits and Globe Valves. Today we're going to be going through a presentation introduction to retrofitting globe valves. I will be your moderator. So we're going to get started. I want to say thank you for everyone joining us today. And if there's any questions along the way, you can add them to the chat and also at the very end. I don't want to miss anything, okay? Thank you again. So today what we're going to look at as far as learning objectives, we're going to go through a couple things today. We're going to start off by looking at a valve make and model, how to locate that information for a globe valve retrofit. We're also going to look up that make and model in our retrofit solutions guide. Coincidentally, up in the files section of your screen, you'll see a couple other choices of files that are up there. One of them is a video and one of them is the technical documentation if you would like to follow along. We're going to also look at when you're selecting two different linkages. We have a couple different choices, the UGVL or the UGLK, when you might pick one over the other. We'll take a look at the specific actuators that goes with those linkages. We'll also look at some of the mounting instructions a little bit briefly and some considerations for each one of those linkages. And then last but not least, we'll take a look at the custom retrofit form and go through briefly on how to fill out a custom retrofit form. And this would be in a scenario where there's no information on the valve. So these will be our learning objectives today. So as far as retrofitting goes, there's thousands of valves out there with actuators that are fairly old. Some of them operate improperly, sloppily, or not at all. So often it's kind of assumed, performance is bad, we're wasting energy. Retrofitting might be a possible scenario over replacement. And the assumption many times is that the valve is having poor performance. The valve must be failing. There must be something wrong with that valve. And in many cases, the true fact is that the actuator is where the problem really lies. An actuator that's not running correctly ultimately has the resolution that controls that globe valve. So what the solution sometimes might be, the obvious choice might be, okay, I'll replace the actuator, like for like. That's somewhat the simple thing to do. When in fact, it's not always the case. Getting like for like, there could be other factors that come into play. You could have an old pneumatic system, and when you put a DDC system in there, that actuator doesn't speak to the new DDC system at all, or might require additional pieces to convert pneumatic to electronic. There also could be issues where the existing model is obsolete. These are just two of the scenarios, but there could be many scenarios where the valve cannot be removed or cost of labor is too high to replace that valve. So the realistic approach would be to replace the actuator with a newer state-of-the-art actuator. Again, you're going to get better resolution on your valve, better performance, which ultimately equals cost savings and comfort. And that's really what we're all shooting after, is better comfort. So if we take a look at the steps on retrofitting, one of the first things and one of the biggest misconceptions is, what am I looking for? The number one thing to start off with is the valve make and model. A lot of people will jot down the actuator because that's sometimes the easiest information to get. And the actuator is only part of the story, but the valve is the most important thing. That's ultimately what we're going to attach our linkage to. So you want to start with the valve make and model. The next thing is, once you get that make and model, you're going to reference the retrofit tech guide or call tech support and see if there's a linkage choice for that. As you go through the book, you'll see if there's a linkage choice. You'll ultimately select your actuator based on that linkage. And then once you select the actuator and linkage, get it and mount it, and you're back up in business. And one of the real key takeaways for retrofit is to be back up and running with very little downtime. That's ultimately what you're shooting for. So if we start off with, like I said, one of the most important things is make and model. Where are you going to find this information? Unfortunately, sometimes you will have to cut away the insulation, but a lot of times the information will be right on the valve casting. Like you see here, it says CB right on the casting. Sometimes there'll be a tag. Many companies, including Belimo, use a brass tag that has the valve body number right on here. You can see in this Johnson Controls example, V3765. It's important to jot down all these numbers. Some numbers, a couple digits, could be slightly off. That changes the whole design of the valve, so getting all the information is important. If the tag is missing or you can't find the information in our book, not to worry, we have a backup plan for that too, either with our universal linkages or a custom retrofit. And we'll go into that in a little bit. So when you have this make and model, the information you're going to grab, you're going to jot it down and come to our retrofit tech guide. There's usually one that we publish every year. The newest one just came out, so you can either order that or download it. It's also up here in your files. So if you wanted to download that book, that's the latest and greatest retrofit tech guide. The next thing you do is take that make and model, look in the table of contents, and find the brand that you're shooting for. It's just good to know. This is the webinar about globe valves, but we also can do retrofitting a ball valve and butterfly valves. So we're going to take a look a little bit deeper into this catalog and see how you would select that appropriate linkage. So in the example we're going to talk about today is going to be Siemens. So you come across a valve in your system that says Siemens. It might also say Landis or Powers. A lot of these people or companies have changed names over time. We try and keep track of what they are and update the book. What we're going to look at today is a Siemens 658 valve. So I would take this information, I'd come into my book, and I would look at the series, 658. The next columns are just informational. They're letting you know that this valve should have been a three-way valve, and it should be a 1 1/4 inch, or that's the valve you're looking at, is a 1 1/4. So each one of these has a couple different models. So we're looking at the 658 1 1/4 size. The next big question is, I'm going to retrofit this valve. Do I need a failsafe? Yes or no? Failsafe would be if the power goes out, I need to fail open or close. Or in our example, we're going to choose no. If there's a power outage, it's going to fail in place. The next thing to know is the system pressure. What's the close-off pressure of this globe valve? On a globe valve, depending on how much you push down, is how much close-off pressure you get. So in our examples here, you see 78, 156. If you needed 100 psi, you might choose between these two. In our example, we're looking for a 200 psi close-off, so you can see there are two choices. The UGVL with an SV actuator or a UGLK 1214 with an AM. So those are the two choices you would get, and you would select the linkage plus the actuator to give you a 200 psi close-off, or more in this case, for that valve. And this is what the two different choices would look like. This is our newest universal linkage with an SV, and over here is our UGLK linkage with an AM actuator. The SV is a linear type actuator that does the rotary to linear motion inside, and the UGLK is a rack and pinion style sheet metal linkage that takes a actuator and turns the rotary to linear inside this gearbox. Both of them, coincidentally, are for water, steam service, and a 5-year warranty. So we'll take a little bit now. These are considerations of why I might choose one over the other. One of the first ones might be, hey, I have a couple AFs left over from an extra job, or some AMs for that Siemens valve. So I might use the UGLK because it uses a regular air side damper type of actuator with the V-bolt clamp. Whereas the UGVL uses these LV and SV actuators that are specifically for that linkage. Another choice could be stroke. The UGLK can do strokes over 3/4 inch, where the LV and SV can do smaller strokes. So if you happen to come across this valve that has quite a bit of travel, the UGVL might not be the choice for you. Multiple linkages. Before the universal linkage came out, there were multiple UGLKs. So in our example, you needed a 1214. If you had the 1 inch, it would have been a 1210. So at any given job, you could have multiple UGLKs with multiple actuators. There's different UGLKs for different families, whereas the universal linkage would fit a whole host of valves. So that could be a nice thing where you're going to carry one in a truck and be able to do a couple different valves that you come across. One's not better than the other. It's just another consideration that you might think of. Control signal. Although the LV and SV comes in many control signals, the UGLK, again, because it uses some airside actuators, if you had a scenario where you needed 0 to 135 ohm, you might want to choose one of our MFT 95 actuators that fit on a UGLK but would not fit on the UGVL. Failsafe. The LVK and SVK are an electronic failsafe, whereas the AF, or anything with an F in the part number, would be a spring return. Some specs today actually go on to say mechanical failsafe, and where you get an electronic could give you a hard time. There are some positive and negatives to both, where the electronic failsafe can be sped up and slowed down. You see this in the next scenario here. The new LVs and SVs can be sped up and slowed down quite a bit, whereas an airside actuator, whatever the speed was on it, there's a very small window to change the speed. So again, these are just some choices or different things to consider when you're selecting. Maybe I'm going to pick the UGVL over the UGLK. It really has to do with your application. What are your needs in your building? And again, these are the pictures of what the two look like. So we're going to go a little bit deeper, again, as far as identifying the characteristics. So like we talked about, there are LV and SV series that would go on this linkage, the UGVL. As you can see, they come in non-spring and also electronic failsafe. You can see there's a whole host of choices as far as input control. And the difference between the LV and the SV is force. Again, remember I said if you push down on a globe valve, it will give you X amount of close off. So if you push down with a small force, like with the LV, you'll get a certain close off, and if you put in SV, because there's more force, you'll get more close off pressure. And we're shooting for 200 psi, so we're looking at the SV. And again, electronic failsafe is with a K. You can either have it fail stem up or stem down, and there's a little dial on the face. Control signal, they come in floating point, 2 to 10, MFT, which is a variable. You can see there's multiple voltages, so you could do 24 or 120 volts. If we take a look at the air side for the UGLK, you see there's a whole host of these here, LFs, NFs. The AM is the one that we're going to be focusing on. You can see there's -3 and an MFT. Gives you a different range of control signals. Now in this slide I only put a couple different choices of the airside actuators, but again, because it could fit virtually any one of the airside type of damper actuators. If you wanted to use something special, it's not on this list, but you could go to our product guide and price list and look at the airside AM page and pick any one of the AMs. And if you needed some specific information, you could go to the technical documentation for the actuators and learn more about that actuator. So again, in our scenario, we have two choices, and we're trying to consider which one might be better over the other. We've talked about the actuators. If we look at mounting, some of the considerations for the universal is to set the stem. When you get the instruction sheets, and every one of these linkages come with an instruction sheet, there will be an area where it's telling you which way you want your stem to go up and down. The instruction sheet will step you through if it was going to be a stem up versus a stem down type of configuration. So you want to take care when you get to that part of the instruction sheet, you make a decision. Do you want it to go up or down? The other important consideration in the instructions is the universal linkage. Because it is universal, comes with different pieces that you can use for either a notch type bonnet or a threaded type of bonnet. There are some other information in there and pieces that let you attach to a threaded stem versus a notch type stem. So it's important on the instruction sheets, this very first step to look at to identify what is this valve I'm about to retrofit. I would encourage everybody either on our YouTube channel or in the resources, there's a video that you can watch about the universal linkage to see how easy it is to install. And this is just a blowout of the entire instruction sheets that come with the universal linkage. It does require a little bit of setup, like I said, before you install it. And in the back page is a full set of wiring diagrams for all the different models that it comes with. And again, here's our YouTube channel if you wanted to take a look at the install video on that. Now, we switch gears for a minute, UGLK. The instruction sheet that comes with the UGLK also has in it for butterfly and ball valve retrofits. This is what it looks like. Each page will give you a step-by-step on how to install that UGLK based on the brand. So at the top page, it'll say Johnson Controls. This is similar to a Siemens. This is similar to a Honeywell, and it'll give you some instructions on how to put that linkage on that specific type of valve. One of the key things to think about for the UGLK, this is just a note, when you're doing a fail-safe. Many times people retrofit a globe valve with an AF or an NF actuator, and they don't know about the 5-degree offset. What we're talking about here is preloading the AF about 5 degrees to ensure that the valve bottoms out before the actuator comes to its full rotation. Essentially what you would have is a call for the valve supposed to be closed, and it's still leaking by a little bit, and you're getting heat when that valve should be closed. That's because the actuator ran out of travel before the valve was fully stemmed down. The instruction sheets will step you through that and how to put that little 5-degree offset. This is just a note here on the differences and some of the nuances between the universal linkage and a UGLK. Okay, so up until now we've been looking at valves that are in our catalog. You found the make and model, and in this case, you come across a valve that does not have a tag or does not have the make and model. There's a couple different things you can do. You can try one of our universal linkages that fits a whole host of valves. Again, it's an adjustable style linkage, either the UGVL for the small NPT valves, or our newest FGVL, which you see here, which is for flange globe valves. It's kind of the big brother of the universal linkage. It fits 2.5 to 6 inch. If your valve is so unique or you don't think it's going to quite fit our universal linkage, we can go back to a custom linkage, in which case you would need one of these retrofit forms. They're located on our website, the tech doc, and even in our PGPL. Important would be to come across this valve, strip it down to the barest form, grab a set of calipers, and you're going to fill out the form to 3 decimal places using a caliper. It's important to note, and it says it right on the form, that since these are going to be custom for your specific valve, they are not returnable. So filling out that form is very important. You can go back and forth with customer service or tech support. We'll make sure the form is right where it needs to be before we cut any metal. So what we're going to go through now is filling out a retrofit form. It's located on pages 123 to 132 of the new catalog. And we're going to go step by step on how to fill out a valve or fill out a form of a retrofit on a globe valve. So one of the first things you want to do is confirm the thread or the stem style and the valve style. These are probably the 2 most important things of retrofitting a valve when we do a custom. And you can see here you can do either a threaded or notch type. And then there's about 5 different choices of what a bonnet might look like. And it'll tell you this one is similar to a Siemens, this one is similar to a Honeywell, or Johnson Controls has that external packing nut many times. And you're going to pick the one that suits your valve the best. And you're going to jot that down in the retrofit form. Right now we're focusing on the valve stem. So in our example, we're going to do a stem style A, which is threaded. You're going to take your caliper and put it on the bottom half of the valve stem, and you're going to jot down in the form, this is the diameter we're looking at, and you're going to put it into the form 3 decimal places. In our example, 0.250. It's important to know that this diameter of the thread and the diameter of the valve stem can vary. I've seen valves that have a 3/8 stem and only a 1/4 inch thread. So again, you want to jot that down. In our example, it's straight. Next dimension, with the back end of the caliper, you're going to get the length of the thread. That's dimension C. And you're going to jot down that in the form. And In this case, it's 0.750. The next step would be to get the threads per inch in the diameter. So you're going to make a measurement of the diameter of the thread, and then with a set of thread gauges, you're going to get your threads per inch. And you're going to jot that down into the form, and in this case, 1/4 is the thread on that specific valve we're working on. If you can't get the thread, not important. Make sure you at least get the diameter. We have a way of making a stem adapter that has set screws that can dig right into the thread. If you can't get the accurate count, not a big deal. All right, so we took care of the thread or the stem. The next thing we're going to focus on is the bonnet and also the thread or the stem up and down. In this case, the next dimension is going to be D1, which is going to be the full stem up position. The max we can do here is 6.5 inches. If it's over 6.5 inches, we would have to cut it down to 6.5 inches. There are some valves that I've seen that have at least 10 or 11 inch long stems. The next dimension would be D3. This is the full stem down dimension, because ultimately what we're trying to get at is D2, which is the stroke of that valve. And like we talked about before, the universal linkage can do about 3/4 of an inch, and the UGLKs can do up to 1.5 inch travels. And you can see this here, 1.5 inch is our max. Coincidentally, the new FGVL, which is our new flange globe valve linkage, can do up to 2 inches of travel in a non-fail-safe actuator. All right, so now we're going to focus on the bonnet. We're going to start with getting the overall diameter of the bonnet, which is dimension E. You're going to get the height of that bonnet. In this case, there's a threaded area, so we're going to write that down. So all along, we've been filling out our retrofit form. Dimensions D1, D2, D3. We're going to get the height of G, and then the overall height, which is H. Now, in this particular valve, we're measuring the threaded part and then the overall height of that bonnet. In some cases, like Johnson Controls, there's an external packing nut. So dimension G would be the threaded area underneath the packing nut. Dimension H would be the total height with the packing nut. Last but not least, on the retrofit form is a section for the actuator. This can be either the existing actuator, so we know a little bit about what it did, or the actuator that you'd like to have on your retrofit kit. And then over here is some information on the make and model, valve size, media, and one of the most important things on this whole section would be the system pressure. That's going to help us decide what actuator we need for your custom linkage. We don't want to put too big of an actuator when only you're trying to close off is maybe 10 psi. When the form's all filled out, the electronic version online, you can hit the submit button. This will go to tech support, or fax it into your local distributor or sales rep, and then we'll process it here at Belimo, get back to you with some information on what the retrofit kit is you need and a price. So that concludes our webinar today with the retrofit globe valves. As you can see here from the pictures, it's quite successful. It could be one of the best things for you when you're trying to get back up and running with very little downtime. Resources, again, are at belimo.us in the retrofit section. Please feel free to send any questions you may have. We're going to open up the floor now to some questions.
Thank you so much, Joe. Now, if you do have any questions, feel free to type them in the chat box, and we will be happy to answer them.
Now, while everyone's thinking about questions, this was the webinar for butterflies, but I would encourage everyone to take a look at our Belimo 101 section. There is retrofitting a butterfly valve on there also, which is very similar to this.
All right, Joe, it looks like we have some questions coming in. What is the is typical lead time on custom solutions?
Okay, that's a good question. I'll answer it two ways. Standard linkages that come right out of our catalog, those are shipping in about 2 to 3 days, sometimes even faster if there's an expedite. Custom linkages run anywhere between 5 and 7 days, depending on the complexity. So a simple type of linkage might be 5 days, whereas let's say a pretty elaborate offset butterfly linkage could be up to 7 days. Okay, I see another question coming in here about a weather shield. We do have weather shields available. There's a weather shield for the UGLK styles. They're a polycarbonate style box that can go over that linkage for outdoor use. And we also have a sheet metal weather shield for the UGVL. So both options do have a weather shield you can use for outdoor. They're not NEMA 4, but they are weather resistant. Any other questions? Okay, if anything else comes up or if anyone has any other questions, please don't hesitate to send them in to us through the marketing@us.belimo address, or please call into our tech support. We have tech support on East Coast and West Coast. They can really help you out as far as questions. Take pictures of the globe valves, whatever you come across. Our guys are pretty knowledgeable on what we can and can't do. Don't ever feel like, hey, I have a valve that I cannot retrofit. There's not too much that we can't do either between our universal linkages or custom solutions.
Thank you so much, Joe, and thank you to all of you who participated in the webinar. We will be posting this webinar and emailing out to everyone who attended and to those who are not here right now. So thank you very much and have a great day.